So this lesson is linear functions and slope-intercept form. And I know that you all at least are familiar with that term, slope-intercept form. It's largely review. But if you remember from the last class, we had this same objective on it, and we had underlined the domain and the range. The thing that will come out a little bit in this lesson is the concept of intercepts, what we mean by intercepts. Right? We're still not, in a way, we're really not talking about zeros so much. And we won't talk about domain and range in this one. But we are kind of addressing this SOL. Let me change my color here. Okay, so again, we've got three entities in math, in algebra, that we're dealing with. Expressions, which we evaluate, equations that we solve, and functions that we graph, right? It's going to take a couple slides to develop that. If you want to copy it, that's fine. I would say that evaluating linear expressions was kind of included in chapter 1. Solving linear equations was chapter 1. But graphing linear functions, that's pretty much what we're doing now. So this, we learned in the last lesson that y equals 3x plus 2 could be written also like f of x equals 3x plus 2. It's called function notation. And you could just interchange the y and the f of x. They essentially mean the same thing to us. Right? We graphed that equation, that function, by making a table of values. Right? Here's our table of values. Remember, where do we get the x values from? Say again? Now you choose them. Remember, when you have an equation, y is solved for x, meaning y is alone on one side of the equal sign, x is in the middle of an expression on the right-hand side. You plug in values of x, and you calculate the values of y. You get to choose the values of x. It's called the independent variable. Right? Then you calculate the value of y, which depends on what you plugged in for x, so it's called the dependent variable. These here you choose, right? You get to choose those values. And you plug them in, and I only did 2 this time, but I got the point 0, 2, and 2, 8. So I graphed them, 0, 2, and 2, 8, and I connected them with a line. We call that linear, right? A linear function because the shape is a straight line. A lot of times when you say, why is something linear, people say, well, because the shape is a line. Well, a line can be curved, and it's still a line. So it's kind of important to say it's a straight line. Good. Deshaun? Allie? So linear equations can be written in 3 forms, and that's what we're going to be doing between this class and next class. This class, we are only dealing with slope-intercept. But in the next 2, we'll be using point slope and standard forms. And each one has its particular use, that makes it more useful for you. Um, by far, the most useful is the one we do today, slope-intercept. And the reason why, because it's already solved for y. It's in the function form already. So that is by far the most important of the three. But I use a lot point slope form when I'm trying to convert grades that are on one scale to grades that are on another scale. I'll do what we end up doing in the next class frequently. Standard form has a very particular use, which we'll see tomorrow. But the slope-intercept form is solved for y, so it's essentially in the function format. Because it's solved for y. Good. Okay. Okay, so slope-intercept form of a line. Again, you're familiar with y equals mx plus b. That's slope-intercept form of a line. Y equals 3x plus 2 is in that format. In the mx plus b, the m represents slope. What is the slope of a line? It's the tilt, right? It's how much is it going up or down. Is it going up really steeply, or is it going up just a little bit? Or is it flat? Or is it going down? Right? That's what that M is telling you there. And the B is called the y-intercept. Does anybody remember what y-intercept means? We're across the y-axis, right? And you could tell in this equation, 3x plus 2, the slope is 3, and the y-intercept is 2. And we'll go into that a little bit more later. Now, the M and the B, they can change, right? They will be all different kinds of values. One or the other of them could be 0, right? And still be a line. What it is that makes the equation a linear equation, it's that both x and y are being raised to the first power, right? If either one of them was squared, it wouldn't have a graph, which is a straight line. So it's this y to the first, x to the first. That's what makes this linear. That's how you know this is going to be linear. So without seeing the graph, we know this function is linear because the exponents of x and y are both 1. Okay. Good, Christian. Okay, so slope, right? The first part of the slope-intercept form is slope, right? The tilt of the line, right? How much is the line going up versus how much is the line going over? You could say it in a whole bunch of different ways here. You could say the vertical change, sometimes called a rise. How much is it rising? The horizontal change is the run. We calculate it by having the coordinates of 2 points, and we label them x1, y1, x2, y2. Now, when it has that little subscript of a 1 or a 2, it means this is a fixed point. It's not a variable anymore. It's a fixed point. We just don't. We're using a general way to represent it because we haven't started a problem yet. But it's not a variable anymore. It is a fixed point on the graph. The fact that we're using different subscripts, x1, y1, x2, y2, means it's 2 different points. And if you've got those 2 different points, you calculate the slope by this formula right here. Right? y2 minus y1, that's the change of the vertical coordinate, divided by x2 minus x1, that's the change of the x coordinate, or the horizontal coordinate. A lot of times it'll say something like, does anybody remember what the equation for slope is? And you'll say y equals mx plus b. Right? That's the slope-intercept form. You're confusing it. There's 2 different things. This is the equation for slope. The slope-intercept form of a line is y equals mx plus b. So as you can imagine, after we present this, we'll do a couple examples where we calculate the slope. Okay, Jaden? All right, so here's the first example. What is the slope of the line that passes through the given points? And here are the 2 points. Okay. Well, let's see. We have a formula. The formula depends on having points, and that one of them is the point x1, y1, and the other point is x2, y2. Okay, well, they haven't told us which is which. Does it matter? Okay, it doesn't matter. Okay, the only thing that matters is you got to do the subtraction in the same direction, whatever you do. Right? So I could say that this is my x1, y1, and this is the x2, y2, and then it would look like this. It would be 4 minus 7 over negative 2 minus negative 3. If I reversed it, then it would look like this. Right, reverse x1, y1 with x2, y2. If we did that, it would be 7 minus 4 in the numerator, divided by negative 3 minus negative 2. All right, let's see what happens to the calculation by switching the order that we did it. 4 minus 7 is negative 3. Negative 2 minus negative 3 is like negative 2 plus 3, which is 1. If I do the same thing down here, I get 7 minus 4 is 3. And negative 3 minus negative 2, like negative 3 plus 2, negative 1. Right? In either case, what does that fraction equal? Negative 3, right? A negative 3 over 1 or a 3 over negative 1, same thing. It's negative 3. And if you notice, because this does come on the heels of what we talked about in Chapter 1 with properties, right? Commutative property is switching the order of things. And we know the commutative property works for addition and multiplication, but it doesn't work for subtraction, because what happens when you reverse the order? Instead of 4 minus 7 is negative 3, 7 minus 4 is positive 3. It makes it the opposite sign. So definitely commutative property doesn't work for subtraction. So whichever, the one mistake you can make here is that you would do 7 minus 4 in the numerator and then do negative 2 minus negative 3 in the denominator. That would be the mistake. Then what would happen to your slope? It would be the opposite sign of what you meant it to be. Okay, try to find the slope between those two. Who's got an answer? Deshaun? Did you do it? Come on, what are you sitting on your hands for? Correct. Did you do it? I can't hardly read that. What does that say? It should be negative, right? Positive or negative. Did you do it, Holly? Yeah. What is the answer? -1, right? If I put it in the format, right, I'll say m equals y2 minus y1 over x2 minus x1. And it doesn't matter which is which, so I'll just say this is my x2, y2, because it's written afterwards. So 1 minus 4 over 8 minus 5. So that would be -3 over 3 equals -1. Did anybody get anything different than that? Here's one thing you want to be careful of. If you decide you're going to do this in the calculator, then you got to have parentheses around the numerator, parentheses around the denominator. Right? If you just put in the calculator straight up, 1 minus 4 divided by 8 minus 5, you're not going to get the right answer. So either put this in parentheses and put this in parentheses. Remember how you enter things as a fraction in the calculator. Do you remember where you go for that? This is real important to know because it'll help you on so many things. Alpha, y equals, and the number 1. And now you can enter it as a fraction. You don't need parentheses. Just put it in exactly already in the fraction format. It helps. Okay. So slope. Definitely, that's a review. Let's see, we're in Algebra 2 now. So let's see. I know for a fact that you had slope in geometry at the very beginning. You had slope in Algebra 1. Did they also talk about slope of a line in pre-algebra? Do you recall? So this is the 4th year, the 4th class that you've had slope. And the reason that they do that, it was kind of an education philosophy that they came up with, which was instead of teaching you a concept to mastery one time, we're going to do what they call spiral learning. And spiral learning says we're going to do it a little bit here, and then we'll do it a little bit the next year, and a little bit the next year, and therefore at the end of it, you're going to learn the thing. And maybe you'll even learn it better than you would have learned before. That was in vogue for about 20 years before they realized that probably we need to be teaching things to mastery. We tend to, even when we get to the 4th time through, make a lot of mistakes with it. It's not like we've mastered it much more than the first time we went through it. So let's say you go from this class to functions or pre-calculus. In pre-calculus, I assign a problem at the very beginning, which is, dealing with functions, titleless functions, just like what we just went through. And it requires them to do something with slope in maybe a little bit different way, a little higher level of learning. Out of 75 kids, nobody even comes close, ever. And that was with the concept that they had the spiral learning for 4 or 5 years. They've been presented with this concept. It's not their fault. It's this method that, people thought would be a better way to learn. Okay, here's 2 examples of calculating the slope that we got to be sure of. But not just for slope reasons of calculating slope, but just about what it is when you get zeros when you're making the fraction, right? In the first one, you do the y2 minus y1, and you get 0 in the numerator, right? When a fraction has a numerator of 0, then the fraction equals 0, right? And that's not undefined. That's fine. That is a number. 0 is a number, right? That's what a 0 slope looks like. The numerator is 0. Again, in lots of classes, we'll get to that point, and students will make mistakes about that particular concept. It's a different thing if when you subtract the x's, you get a 0, because now you got a 0 in the denominator, right? If it's not clear to you yet, do it in your calculator. What do you get when you try to divide by 0? Error. It's going to give you an error. Let's watch this. If I do 2 divided by 0, enter, divide by 0, it's an error. You can't do that. I mean, just think of what it means to divide. You know, if I got a pizza and I divide it into 8, I say divided by 8, it means divide the whole, which has a certain area, into 8 equal slices, right? If you said divide it so that how many slices would you have if each slice had an area of 0? Right? How many do you have to add up that each have an area of 0 to get that pizza? Would you ever get to the pizza if actually each thing actually was nothing in itself? No, you would never get there. So this here, you can't divide by 0 because you just can't divide anything into a bunch of smaller pieces that each one is just a 0 by itself. Right? It doesn't make sense for division. Right? So when you get this kind of thing, that's undefined. That is a slope which is undefined. Not to be confused with that. 0 is not undefined. It's a number. It's a number right in between negatives and positives. Right? It is a valid number. Now, when you look at all the different variations of slope, right? You have positive slope means that the line is going up from left to right. So if I'm looking at this thing from left to right, it's going up. Positive slope. Negative slope means that it's going down as you look from left to right. Okay. The slope of 0, like this, means that it's not going up and it's not going down. Right? It's not positive, it's not negative. I mean, 0 is right in between those two. It's not positive, it's not negative, it's flat. Okay. Is that a function? Sure. For every x value, how many y values do you have? 1. It passes vertical line test. A horizontal line, you name like this. You write it like this. Let's assume that's a 2. Y equals 2. You don't see an x in there because it doesn't depend on x. For every value of x, there's the same y coordinate. So a horizontal line is y equals a number. Right? And every point on that line is the same y coordinate. It's 2. The vertical line is the one with the undefined slope. Because even if you tried to say, what is this line doing as I'm looking at it from left to right? It's not going left to right. You can't even apply that standard to it because it's not going left to right. It's just stuck in one place. Right? There's no left to right about it. That's the one that has this slope. Now, the equation for that is, what's the x coordinate for every point on that line? -2, right? So that's the equation. X equals -2. Right? It's got infinitely many y coordinates, but it's got one x coordinate, -2. That's how you name it. Do you have a question? No. Okay, so what was the other thing I was going to say about that? Is this one a function? No, it's not a function. Now, here's the thing about, if you want to graph these things in the calculator, where do you go in the calculator to graph anything? You go to y equals, right? Well, y equals works for all of these three. There's a y equals in them, right? Which is the only one that doesn't have a y equals? The vertical line. So you can't put the vertical line because it's not a function. This button right here is specifically where you put functions. Right? It doesn't deal with vertical lines. Okay. So the intercepts of a straight line or of any function are where they cross the axes. Right? So you have, in order to understand the intercepts, you kind of have to understand the way the x's and the y's work, right? The x's are how far you go to the left and the right on this axis right here, right? But every point on that line has a y coordinate of what? What is the y coordinate for every point on the x-axis? It's 0, right? In the same way, the y coordinate is telling you the ups and downs, right? So But every point there is not to the left, it's not to the right, it's right in the middle, so we would say that x equals 0 on the y-axis. And that's important, not just for linear functions, but for all kinds of functions. You know, the number one tool for finding the intercepts ought to be, if you want to find the x-intercepts, plug in y equals 0, solve for x. If you want to find the y-intercepts, plug in x equals 0, solve for y. And that's how you find them. Okay, that's what we mean by the intercepts. Now, we're only interested in one of them today, right? The y-intercept. Next class, when we do the standard form, then we deal with the x-intercept too. Okay, so we're going to do some side-by-side things, right? Here, we've got a worked out problem, and then we're going to try to use this to do this right next to it. And you got homework that are just like that. So if you can follow this and then repeat it there, it's kind of a, I don't know whether I said this one to this class or before. There's probably in the top 5 sports coaches in America ever, and nobody would even dispute this, is John Wooden. Does anybody remember John Wooden? Read about history, anything? In the 1960s, early 70s, John Wooden was the coach at UCLA, right? UCLA basketball. They won like 10 NCAA championships in a row, 10, 11, 12, something. It was every year they won. They were really, really good. If you remember names like Kareem Abdul-Jabbar, Bill Walton, Gail Goodrich, a lot of good players. He says, and I read it in an education book, he said, all learning can be broken down into these 4 steps: explanation, demonstration, imitation, repetition. I can imagine as a basketball coach, that he's trying, try to imagine, I don't know if we got any basketball players in here. You're a basketball player, right? No? His email address, that made me think so. Try and imagine trying to teach like a big guy, how his footwork that he's supposed to use, which is not exactly natural. I mean, you think the guy's just running around jumping and that. There's a lot of science to what these guys are doing, and you're trying to teach. So you explain what you want the guy to do, you demonstrate, and then he's got to like try to imitate, and then he's got to repeat and repeat and repeat. Because in the end, it just has to be like part of his muscle memory that he's not thinking anymore. He's just doing it the right way. I think that works pretty well with math too. We explain, we demonstrate. At a certain step, you're going to imitate. You may not understand exactly what's going on, but you can see if you could repeat the steps. If we're looking at these steps, could we repeat the same steps over here? And then what do you think the repetition part would mean for us? What is it that we do that would be the repetition in this 4-step process? Homework? Practice it. Okay. So, when you're doing the imitation part, and I'm just saying, this is not like because we're trying to frustrate you. I tell you, as a math student, my whole life, it was very common that there was a certain point you were doing the imitating without really understanding very well, but it came through the repetition that you'd start to say, oh, I get it. I see what we're doing here. I'd call those a math moment. It'd be like, bing, the light goes on. I get that now. But sometimes when you walk out of here, it's not totally unexpected that you may not 100% understand the lesson, start to finish, like it's just a piece of cake. It takes a little time. So in these problems here, they're giving us the slope and they're giving us the y-intercept. And we need to plug into the y equals mx plus b form, right? So what is it that goes in the place of m? In this problem, it's the 1/5, right? Put that right there. Okay. Now the y-intercept, they're giving us coordinates, right? It says 0, -3. So which is the number that's getting plugged into the y-intercept? The -3, right? Remember, the 0 is because on the y-axis, x is always equal to 0. That's what you expect. So you plug that in here. So you substitute, and if there's any simplifying to do, you simplify it. Okay. So let's try to do the same one here. What will be the slope-intercept form of a line if it has a slope of 6, y-intercept is 0, 5? Y equals 6x plus 5. right? That just, look at what we did over here. Do the same thing here. This goes here. This goes here. Right? Not too hard. Good. Okay, determine slope-intercept equation from a graph. Okay, so here's an example where they've worked the whole thing out, and then we'll try to do the same thing that they did there down here. Here's our line. We need to know two things, right? We need to know the slope and the y-intercept. The slope is how much is this line going up and down divided by how much it's going left to right. And they've drawn these on the graph, and they've actually put these points there. You don't always have the points highlighted for you, but if you don't, you're looking for some place, usually, where it looks like it's crossing at the intersection of grid lines. So both of your numbers are whole number integers, basically. I mean, you don't want to like take this point there. You know, you can have fractions for both. You're just estimating. Try to look for a place that it crosses the intersection of grid lines. Right. So now, you know, this is the change in the y. How much are we going up or down to go from this point to this point? It's down 3, right? And down 3 is like, you know, m equals down 3. Okay. Now, in the x direction, we're going right 1. So that would be down 3, right 1. Okay, what if you went from this point to this point? Then it would be up 3 and left 1, right? But it's still, when you do the negative 3 over 1 or 3 over negative 1, it's still the same thing. Your slope is negative 3. So that's where this comes from here. Just read it off the graph. How much is it going up and down divided by how much is going left and right? Okay. And then what's the y-intercept? They've labeled it already on the graph. 4, right? Positive 4, right? It would be different if it was down here, but up here it's plus 4. So that is here. Okay, look at this graph. And I guess the 2 points we're using are this point and this point. What is the slope going to be? How much am I going up and down? 3. Down 1. And how much am I going left and right? 2 to the right, okay? So the slope is, right, it's down 1, right 2. How does that look like with numbers? Down 1 is negative 1, and right 2 means positive 2. Right? You're getting these because, you know, in the y direction, negative is down, positive is up. X direction, negative is left, positive is right. And what is the y-intercept? Negative 3. Right? So the b, or the y-intercept is 0, negative 3. So what is the equation of a line? Y equals negative 1/2 x minus 3, plus negative 3 or minus 3. Either one is fine. I'm sure there'll be some homework problems that are just like that too, right? You got to be able to look at the graph and tell the slope, look at the graph and tell the y-intercept. If they don't have these, you know, drawn for you already, just look for some place where they cross the intersection of grid lines. Okay, write an equation in slope-intercept form that's not already given to you in slope-intercept form. So here's their example they're showing us. Right? 5x minus 4y equals 16. How do you put that into the slope-intercept form? Solve for y. Solve for y. Right? Because remember, the slope-intercept form is y equals mx plus b. So the y is isolated on one side. I mean, this is kind of why in chapter 1 in the solving equations part, you had to solve some equations that had more than one variable. Okay, well, this is it. I mean, that's why we've got to be comfortable solving for y in terms of x, right? It's not all going to come down to one number. There'll be an expression on the other side. So let's see what they did in this problem. The first thing they did is they divided by the 5, or they subtracted the 5x, right? That moved, the 5x was positive here, it's negative there. And then they divided by -4. Right? So if you divide by -4, that means every term divide by -4. Right? The -4 over -4 cancel. -5 over -4, the negatives cancel. Now it's positive. And 16 over -4 minus 4. Okay, that's in slope-intercept form. Okay, now that it's in slope-intercept form, what is the slope? 5 over 4, right? Don't try to answer that question looking at that, right? Wait till you've solved it for y, then you can answer that question. What is the y-intercept? -4, okay. So let's try to do the same thing here. What would be, if I'm doing the same first step here as they did there, what is it? All right, subtract 3x. Okay, now here's a key point. How are you going to simplify this right here? 18 minus 3x. Are those like terms? Can you put them together? No, don't try to put them together. You know, I mean, we make a lot of mistakes with that kind of thing. Notice when they subtracted the 5x from both sides, it just showed up as -5x on the other side, plus the 16 that was already there. So what will ours look like? -3x plus 18. Now, would it be the same thing if we said 18 minus 3x? Can you switch the order when you add things? Commutative property of addition? Sure, you can. But we want it to look like that. We want the x term to be first. So it's probably better to write it with the x term first. But it's not wrong if you said 18 minus 3x. Because of commutative property, it doesn't matter the order. And then what would be our last step? Divide by 2. So divide 2, divide 2, divide 2. Okay, y equals -3 halves x. And the 18 over 2 is 9. Okay, try to do the same thing there. See what you get. We're almost done. This one is going to be 7. Get it? Okay. 5 over 5 is not 6. It's a multiplication table thing, yeah? Okay, what are we doing here? Remember, you're going to add 7x. To cancel a minus 7x, add 7x. Don't do it like minus a negative. You won't get all confused. Just add 7x, add 7x. And so that is a positive 7x. Then what happened to the 35? Just say plus 35. And then, so what's the next step? No, just put 35. And then what do you do? There we go. Good job. Good. What was the slope? -7 over 5. And what is the y-intercept? -7. -7. Okay. Alicia, not working? Okay. So the right steps would have been, okay, add 7x to both sides. Because that's a minus, to cancel what we want to add. Okay. So now we've got -5y equals 7x plus 35. And I see a lot of mistakes where like you stop using the x. You just don't put the x in there at all. So make sure it says 7x. And then divide by -5. And then the -5s cancel. Y equals -7/5 x minus 7. Now, if somebody asked, we would say the slope is -7/5, right? Don't give the x as part of the slope, right? The x is not part of the slope. The slope is the coefficient of x. It's the number in front only, right? It would be a mistake to say -7/5 x, right? I'm sure there's homework problems just like this. And then the last, using slope-intercept form to graph a line. First of all, if it's not in slope-intercept form, you got to put it in slope-intercept form. Again, how do you put it in slope-intercept form? Solve for y, right? So this -2x plus y equals 1, right? They added 2x to both sides, and it was in slope-intercept form. Okay, when you graph, and they've done a pretty good job on their graphic here, which is step 1 is plot the y-intercept. So the y-intercept is 1. That means you go to 0, 1, and put a point. Right? Then you use the slope to find another point on the same line. The slope in this case is 2. So how should I use that 2 to direct me to another point on the line? Remember, the m is 2. So you want to say that's like 2 over 1, because you need some amount to go up and down and some amount to go left and right. So you make it like a 2 over 1. So +2 is telling you to go, in the numerator, is telling you to go up 2. +1 in the denominator is telling you to go right 1. So not from the origin, not from the middle of the graph, but from the y-intercept, you go up 2, right 1, make another point, right, and connect with a line. You know, if you're not proficient at this, you kind of need to get it there someday. You know, this is just considered to be so basic. It really should have been taught to mastery in Algebra 1. Unfortunately, it probably wasn't. Because you got a calculator. People tend to say, oh, I'll just put it in the calculator. But then the understanding of it is kind of lost. Okay, so this is a last example. Graph this. What do I need? 4x minus 7y equals 14. If I want to graph it, what do I have to do first? Solve for y. Because at this point, the only form that we're using is slope-intercept form. We need to put it in slope-intercept form. So what will be my first step? Subtract 4x. So now we've got -7y equals -4x plus 14. Remember how we're dealing with this right-hand side. I'm putting the -4x first so that it looks like mx plus b. And I'm not trying to combine like terms. There are no like terms. Last step, divide by -7, all 3 terms. Right? So this is y. Did I mess that up again? Darn it. Y equals 4/7x minus 2. So you see I messed this up because I should have had this going down further. All right, so what's the first step? According to what they had on the last side, the first step is, and the y-intercept is -2, okay? Plot the y-intercept. Next step. Go, right, m equals 4 sevens, right? So we're going to go up 4, right 7 with a big fat writing there. 1, 2, 3, 4, up 4, 1, 2, 3, 4, 5, 6, 7. And there's the line. Okay, let me go back to that marker, small. And I'm sure there'll be homework problems like that too. Basically, all the homework problems be like those 4 examples that we did. Before I put up the homework, that was what we did today. For those of you that are interested, there is this website, which you don't need a password or anything for. It's called interactmath.com. And if I go to here and here, this is what it looks like when you go there. Interact Math. Okay. If you hit enter, then it'll ask you to pick your book, right? Our book is Prentice Hall, Algebra 2, 2011. Submit. And you could see when you do that, the picture of your book is there. So you know it's your book. And then for each chapter and for each section, for example, the section we're doing right now, which is 2-3, what they do is for certain homework problems, not all the homework problems, but for certain homework problems, you know, solving equations. What is the matter with this? That is an Algebra 1 book. Prentice Hall Algebra 2. That looks better. Okay, 2-3. Yeah, 2-3. They give you, for some of the homework questions, they give you like another problem of the same kind if you wanted to practice more of it. I think our homework is going to end up being the 9 through 35. So you can see here, 9 through 35, they have starting with 11 and going up through 31. You know, if you wanted to practice more, there's more practice right there. And when you do it, let's say I go to 31. You know, you can check your answer, you can ask for help, all kinds of things. So I just wanted to point that out. There's been some that have been in preparing for the first chapter test, you know, and they came after school, we played around with this a little. I think, you know, the ones that came said they were going to use it. I don't know if they did, but I just wanted to show it to you. Okay. Okay, so that's the homework finished.